Okay, so here's a question that we're going to try to answer today. We're going to try to solve this differential equation. And our differential equation is t natural log of t times dr dt plus r equals t times e to the t. So our unknown is r, right? And r is a function of t. So we're essentially going to be solving for r. Let's see here. We can make this a little smaller. All right, so the method that we're going to use is integrating factors. Remember, we talked about how we could use the method of variation of parameters or integrating factors. We now know two methods, so we're going to practice using the method of integrating factors. Okay, so the first thing I want to do is actually rewrite this differential equation. So let's see here. So let me go down a little bit. So I want to rewrite the differential equation. And here's how I'm going to rewrite it. First thing I want to do is I want to rewrite it so that instead of having dr dt, which is Leibniz notation, I'm going to use prime notation. So I'm just going to rewrite this using prime notation. So I'm going to start off with t natural log of t r prime plus r equals t e to the t. So that's it. All I did here was just kind of rewrite this dr dt. I just rewrote it as r prime of t. Okay, now the next thing I want to do is I want to put this into general format. So remember, the general format for a linear first order differential equation is, do you remember what it is? Is y prime plus p of xy equals q of x. So here, instead of having the unknown of y, we have the unknown of r, right? So in our independent variable is t, so we have t and r, whereas over here we have x and y, but that really doesn't make that big difference. I'm still going to divide this. I want to get this to look like r prime plus something times r equals some other function in terms of t. So I'm going to divide both sides by t natural log of t. Okay, so I'm going to divide both sides by t natural log of t. Okay, and I'm going to end up with, let's see what I end up with. So I should end up with r prime plus 1 over t natural log of t r equals t e to the t divided by t natural log of t. Okay, and I can rewrite that as r prime plus 1 over t natural log of t r equals e to the t over natural log of t. So at this point I can tell my p of t is equal to 1 over t natural log of t, and q of t is equal to e to the t divided by natural log of t. Okay, so again we get these coefficients. The p of t is going to be the coefficient in front of r, and the e of t over ln of t, which is going to equal the q of t. Okay, so it's the same. You've got some coefficient in front of y, and then another coefficient at the end. Okay, so I've got my differential equation set up. Now it's in the general format. And now I'm ready to determine my integrating factor. So my integrating factor, remember, we already figured out what makes the integrating factor method work. My integrating factor is going to be e to the integral of p of t dt. So that's going to be e to the integral of 1 over t natural log t dt. Let's see here. Can you see that? Okay. So now what I need to do is I need to calculate the integral of 1 over t natural log of t. So let me kind of move to the side. I'm going to make my handwriting a little smaller here. And as a sidebar, I'm going to compute the integral of 1 over t natural log of t dt. And I'm going to do that using u substitution. So I'm going to let u, because remember this is the same thing as the integral of 1 over natural log of t times 1 over t dt. Right? So in fact we can even get in closer. So if I let u equal natural log of t, then du is equal to 1 over t dt, right? So I can rewrite this integral as the integral of 1 over u du. And I know the integral of 1 over u du is going to be natural log of u. Now, at this point, I'm not going to put plus a constant because the integrating factor is just a function. I don't need a general function. I need one particular function to be my integrating factor. So I don't need to have add plus c. Now, the natural log of u is really the natural log of t. Right, because we originally had that u is equal to natural log of t. So I was able to compute this integral. So the exponent in my integrating factor is actually the exponent is natural log of t. And now I know my properties of logs. E and natural log are inverses of each other. So I can simplify this to natural log of t, right? So the e and the natural log will cancel each other out, and I'll just have natural log of t. So my integrating factor is, so I of t is equal to natural log of t. Now I go back and I'm going to multiply my equation. I'm going to multiply my equation. Remember, we put the equation in the general format. So I'm going to multiply this equation by my integrating factor. So that's going to be my next step. And so in fact, let me switch papers here. So maybe I can copy this. Copy. Paste. Okay. And then my integrating factor we said was going to be natural log. Natural log of t. So I'm going to multiply natural log of t times both sides of my equation. E to the t over natural log of t. This is my next step. Okay, so I've got r prime plus 1 over t natural log of t times r. Okay, and things should cancel out, and they will cancel out. So let's see here. So this natural log of t in the numerator and the denominator will cancel each other out, so that's easy. So over here we'll have equals e to the t. The right hand side will be e to the t. And what about the left hand side? Let me just expand right? So I'll multiply here, and then I'll multiply it by here. So for left-hand side, I'll get natural log of t times r prime, okay, plus natural log of t times 1 over t natural log of t times r, okay, and now here, I'll be able to cancel some stuff out, natural log of t in the top and in the bottom. Okay, so my left-hand side is going to be equal to natural log of t times r prime plus 1 over t times r. And that, again, is equal to e to the t. This left-hand side is equal to the derivative of natural log of t times r. So I can rewrite this as natural log of t times r prime equals e to the t. Now let's just verify that. So some people can figure this out, in their head, but let's just verify. Suppose you're a skeptic and you're saying, hey, I don't believe that the derivative of natural log of t times r is equal to natural log of t times r prime plus 1 over t times r. Let's just go ahead and compute that on the side. We're just going to use our product rule. So if I've got, sorry about that, if I've got natural log of t times r prime, now here's the deal. Let me rewrite this actually. I'm going to rewrite it showing kind of what we're really working with. So we've got natural log of t, and then we've got r of t, right? Because remember, r is a function of t, and I want to take the derivative with respect to t of that. Now this is going to be, now what do we do? So our rule is f times g prime is f prime times g plus f times g prime. So I need the derivative of the first one. What's the derivative of natural log of t? 1 over t. So it'll be 1 over t times r of t, okay, plus natural log of t times, I need the derivative of the second one. I don't know the derivative of r. The best I can do is just write down r prime of t, right? And so now this is the same thing. It's just 1 over t times r plus natural log of t times r prime. And that's exactly what we have up here. So let's see here. So do you see this right here, this left-hand side, is precisely the derivative of natural log of t times r. Okay. So now that we know, because remember our whole goal is to solve for r. We're trying to find r. Once we know that the derivative of natural log of t times r is e to the t, we're good to go. Because now I can say, I can integrate, and I can say the integral of natural log of t times r times the integral of the derivative is equal to the integral of e to the t dt, right? I'm just integrating both sides. So it's like I'm just integrating dt, right? That's what I did to get this step. Now, fundamental theorem of calculus says the integral of the derivative is the original function. So my left-hand side is equal to natural log of t times r. And now what is the integral of e to the t dt? E to the t. Here, I'm going to add a constant because I'm solving for r, right? And I want my r to be general form. And I'm almost done because if I know that r times natural log of t is equal to e to the t plus a constant, all I have to do is divide both sides by natural log of t. And I know r explicitly. So this is my final answer. So we can write down, so r of t is equal to e to the t plus a constant divided by natural log of t. So there we go. So now what I'm going to do now is I'm just going to kind of review. Let's review actually what we did and kind of add steps. Like, what are the guidelines? The guideline to solving a differential equation using the method of integrating factors. Okay, so the first thing we did was we rewrote. So this is the given differential equation. So we rewrote it in the general format. So let's put that here. Step 0 is to rewrite equation in general format. And what's the general format? Again, over here, the general format is y prime plus p of xy equals q of x. So that's step 0. Now we're ready. Step 1 is going to be to compute the integrating factor. So I'll just say compute I, right? It might be I of t, it might be I of x, but you're just going to compute your integrating factor. And now what's the formula that we use? The formula is I equals e to the integral of p. Right? So now once you've put from step 0, you're going to be able to tell p and q, right? So your integrating factor is e to the integral of p. So you integrate p, and then that's your exponent for e, and that's how you get your integrating factor. Now, so we got our integrating factor, which was down here, right? To get to integrate, you might need to here's where you're going to use your Math 3B skills, your integrating skills. You might do U substitution, you might do partial fractions, you might use a method. Who knows what method you'll use, right? You can just jump straight to this formula right here for I, okay? So that's step 1. Let's go to step 2. Step 2 was to multiply. Now, what are you multiplying? You're multiplying your equation in the general format. Otherwise, the method won't work. So step 2, multiply equation in general format. And you want to multiply it by your integrating factor I. Okay, so remember, we had our given equation. Our given equation was different from the equation once we put it in the general format. You want to work with the equation in general format. Okay, so you're going to multiply the equation in general format by I. Okay, and the result, and you're going to multiply the equation in general format by I. Then you're going to group together the left-hand side. The left-hand side should end up being, so your left-hand side should be I times y prime. So now again here, our unknown is r. Do you see our unknown is r? But I'm just using y because that's the typical unknown. So the left-hand side, after you multiply, should be equal to I times y prime. Okay? Now you're ready for step 3, which is to just integrate. So the left-hand side should be this, and let me put up here that the right-hand side should be just I times Q. Okay, so at this point you have I R prime equals I Q. Now we're ready for step 3, which is to integrate. Both sides of the equation. IY prime equals IQ. So you're going to integrate both sides to isolate y. Okay, so you're going to integrate and then you're going to divide. So you'll get like the integral of IY prime equals the integral of IQ. So then using the fundamental theorem of calculus, IY must be the integral of IQ. Now here you should have plus a constant. Okay, and so then y is going to be equal to all of that divided by I. See how we're doing that? We're just dividing both sides.
9 hours.
Just divide both sides by I, and you get y by itself, right? Integral of IQ plus a constant. Okay, so that is that's the general method. You've got your step 0, which is to rewrite your given differential equation in general format. Step 1, which is to compute your integrating factor. Okay, and we've got a formula for that. So we've got a formula for your integrating factor, compute your integrating factor. Step 2 is to multiply your equation by I. You'll end up with a new equation, which is I times your unknown. The derivative of I times your unknown is equal to I times Q. And then step 3 is to integrate. Okay. And then when you integrate, you'll get IY. So you need to integrate and then divide by I. So the idea, and I kind of tried to emphasize this in class, that the idea is not necessarily to memorize these steps. That's not really the idea. The idea is to kind of absorb why the process works, right? And in part of absorbing why the process works, it is to see, oh, okay, when I multiply the left-hand side by that integrating factor, it allows me to rewrite the left-hand side of my differential equation as someone's derivative, right? So I can use the product rule. So, and that's what drives this whole method. All right, thank you. I hope that was helpful.